Hi everybody, nice to see you again. Today I have no dyno video for you, but this time I have a repair video. And I'm showing the repair of a Punch 300X, which is a 4-channel amplifier with 37.5 watts of continuous power into a 4-ohm load per channel. If you like, you can watch me repairing this amplifier. I'm really happy and excited that I'm in touch with David Stevens, who was working at Rockford Fosgate in the 80s. Thank you very much for all your help, suggestions and your knowledge.
So the next step is that I checked these 4 guys here. They were intact, everything alright. And of course I checked the bigger ones for the power supply, and these FETs are dead, completely short. I'm going to cut the legs and remove them from the board. Then I will use all screws and take out the burner for the MEHSA strips. And after all parts are changed, I turn all 4 adjustment pots for the idle current completely counterclockwise. After removing all the screws here on the MEHSA strips and the 4 screws on the mainboard, you can take off the mainboard and put the heatsink away. I'm going to cut the legs of the FETs. Next step is removing the thermal paste. This one here is a nice tool if you want to attach the transistors to the MEHSA strip. Nice flamethrower. I'm going to remove them, but you have to take care not to burn the mainboard or nearby components. Now I'm going to remove the FET from the MEHSA strip. Should go really quickly. You can see the solder. Be careful. That's it. And if you install new ones, you just should add some solder on the back side of the FET to have a better connection. Here's a view of the other side. It did not burn or damage any parts of the mainboard. So it's a clean job with this little flamethrower. I have one is removed, the other one should go off well in the next seconds. So I got it. So I really love dealing with this MEHSA strips and with a flamethrower. It's nice. Here you have a better view of the mainboard, the back side of the mainboard, and everything is okay, nothing is burned. So I'm happy with the remove of the power supply FETs. Remove the remaining legs which are still in there. And after I pulled the legs, I heat this hole here, take out this tool, and you have clean holes to put new FETs in the next step. I exchange all transistors from the same production date. If you want to get these SMD resistors out, it's easy, just heat both directions and then it slips off the solder pads. Here you can see the spare parts. Here are the 4 SMD resistors with 27 ohms and the 4 power supply FETs. And here you have something like a date code, and they should be all the same. And then you can install them and you will not have any trouble in future. Now I install the new gate resistors. First pad is soldered to the board. Push it down, heat it up, And the other side again, one more time. To make sure it's in place. Now this one is good. As I said before, I heat up the back of the new FETs and add some solder. Then I will have a better connection, that's enough. Don't take too much time, you can kill them if you apply this heat too long. The gate resistors on the other side are also installed here in this position and this position. Now I take one of them, take something like this, do it like this, the other one also. They will fit without problems. Then I solder the legs so the sky is sitting in the correct position. Then put in the next one. After this, I solder the legs from the bottom side, of course. The first FET is attached to the MEHSA strip. Looks okay. And now I clamp down the next one. Now I start to heat it up. And I just wait until it starts to melt and connects with the MEHSA strip. Now it's melting. I will apply a little bit longer, not too long. It looks okay. And now I let it cool down again. So it looks nice. Doesn't look too bad. I lift it a little bit for you. So it looks okay. And it's working. So usually you have solder here and it doesn't look very good. But in this case it worked well. And now I'm on the other side. I'm clamping the first transistor, not both, just the first one, to the board. Use my flamethrower. And then you have to check out when the solder is melting. It should happen in 10 to 20 seconds, sometimes a little longer, depends on the temperature. It's connected. I remove my torch. And after waiting some moments, I release a clamp. It connected well, so I connect just the next transistor, clamp it down. I'm going to turn on my torch again. Now let's see. Can use a little more power, but not too much. It's melting. Here we go. That's it. Just a closer view of the new FETs attached to the MEHSA strip, both sides. I think it looks okay. After powering up the amplifier, I saw that the amplifier pulled around 0.7 amps and switched on, but the power LED wasn't illuminated. I checked the power LED, it was okay. And the second step is that I think that the resistor in series to the power LED is open, and I measured the resistor and it was open. So I have to replace also this small SMD resistor. Now I try if the amplifier's bias is enabled, and I have idle current of 0.77 amps and all pots for the idle current adjustment are completely counterclockwise. So I turn slowly one of them to the right and I check if the idle current is starting to grow. It goes up. So that's a small test. Now it's time to put the mainboard back in the heatsink and do some audio tests. But if you put the mainboard back in the heatsink, you have to apply new thermal compound. In some amplifiers the thermal compound is okay, but in this case it was something like dust. And I have the RCAs connected to the fronts, and I'm going to check the first front output. This one is working. The right front. Also working. Rear output, sorry. Also working, and the next channel. So this amplifier is working again. Now I'm demonstrating how I adjust the idle current, and the idle current can be set with this pot. Now it's turned completely counterclockwise, and I show you what it looks like on the scope. On the scope it shows this kind of distortion, crossover distortion, and now I'm turning the idle current adjustment pot slowly to the right until the distortion is leaving. Power test of this nice little amplifier, and I have connected a 4 ohm mono to the front and 4 ohms mono to the rears. That means I test the power into 2 ohms per channel, all 4 channels driven into full power. This is just a short dyno and not detailed because I already made a video of the 300X. Into clipping. There's clipping. I go back. That looks okay. Negative waveform is not okay. We can take this one. And I try to check out the voltage. So we get 38.8 volts, 96.5 watts into a 2 ohm load per channel, all 4 channels driven into full power. So the amplifier is able to deliver almost 400 watts.
If you like this video or you have some questions about the repair job, let me know in the comments. Thank you very much for watching, and see you next time on another Amp Dyno video. Bye bye!